This is about creating hallucination-resistant Gen AI applications in pharma. A few weeks ago, we published PlaceboBench, a benchmark to see which one of the LLMs that are out there currently are actually best performing on a pharmaceutical use case. A lot of the hallucinations were fabrications. It's information that's basically made up. But what we also saw a lot is the insertion of world knowledge. Even though we prompted the LLMs to not use their own trained world knowledge, to only rely on the documents provided, they still did that a lot. We saw significant differences in the performance of the models. Especially surprising to us was how badly the new Sonnet and the new Opus models performed. They ranked very high in general leaderboards and especially in coding leaderboards. They're very famous, but what we noticed, they had a very strong tendency to appease. So they wanted to give advice and be helpful and, give recommendations. But really, the last thing you want from an LLM when it comes to medications and drugs is that it gives you advice that you don't really know where it's based off of. 3 of the Gemini models, you can tell they're pretty low on the hallucination rate, as we just saw. And they're also in an acceptable range of latency and cost. The other models that have a, let's say, acceptable hallucination rate, like GPT 5.4, are just very expensive and very slow. So definitely you can see the Gemini models are the star of the show. If you take away one thing from PlaceboBench, it should be that neither size nor cost nor, let's say, fame of a model really indicates if it's going to do well on your personal use case. Whatever you build, you have to make sure you're using the right model for this specific thing that you need from them.